Okay, here we are given the graph for f of x, and we are going to answer these questions. And these are pretty much the limit questions. For now, we'll be using these notations, and later on we'll see that we can write the following. If you have y approaching some number L as x goes to some a value or infinity like this, later on we will see that this right here, we'll write it as the lim for limit, and we put the x approaching a right here. And usually you write down whatever the function is, so we'll say f of x, which is the same as the y, and the answer is L. So that will be just a notation. That will be more in the calculus class later on. All right, for now, let's see. First, we are going to figure out y is approaching to what? As x approaching 3 minus. This means we are going towards 3 from the left-hand side. So we can use our left hand, and you see that the x value 3 is right here, and just kind of trace the curve. You see that the curve, when you approach 3, the curve actually goes straight down. Therefore, the y value goes to negative infinity. On the other hand, if we have x approaching 3 plus, use our right hand, going to 3 from the right hand side and just trace on the curve. You see that the curve actually goes straight up. So we have positive infinity. Yeah. Next, x approaching 4 minus. 4 is right here, and if you, again, left hand side because of the minus, use our left hand, trace it, and you see that the y value is approaching 2. And you might be wondering, hey, there's nothing there. It's an open circle. But we don't care about the actual value at this x equals 4. We just care about what the y value is approaching. That's the idea. We're just trying to observe the behavior when x is around 4. So again, the curve is approaching 2. Pretty much the y value for the open circle. So here we have the 2. On the other hand, when we have x approaching 4 plus, use our right hand, approach 4, right? So just go, and again, you see that the y value is approaching 2, the y value of that open circle. So that. All right, and then lastly, we have these two, which is actually about the horizontal asymptotes. When x is approaching negative infinity, that means we look all the way to the left. So if you just try to trace it all the way to the left, you see that the y value is approaching positive 1. So that will be 1 right here. And lastly, if we go on to the other direction, x approaching positive infinity, like that. So it will be 1 as well. Yep, just like this. All right, that's pretty much it. And now let me just give you guys some more information just in case if you see like other questions relating to this kind of pictures. First, once we have this picture, you should be able to identify the horizontal as well as the vertical asymptote. Let's go ahead and do that. Let's say we have the vertical asymptote. This right here is just at x equals 3. So when you write this down, you're trying to say that vertical line equation right here. And then we also have the horizontal asymptote, which is this one right here, and that's when y is equal to 1. And the vertical asymptote is where the y value goes straight up or straight down, yeah? And you see that that's right here, x is approaching 3 minus or 3 plus. This right here goes straight down, this right here goes straight up. Sometimes you can actually have one-sided asymptote. I'll show you guys that in a later video, but for now, that's what we have. Then we also have the horizontal asymptote, and that's the case when x is approaching negative infinity or positive infinity. Yeah, so for now, they are the same number, so we only have one answer. Okay, and then let's look for the domain. Be careful though, because when we have a vertical asymptote, x is equal to 3, but that doesn't tell you the whole domain right away, because we also have to pay attention to the open circle. So for the domain, x cannot be equal to 3, x cannot be equal to 4. So let me just write this down right here for you guys first. X cannot be equal to 3, x cannot be equal to 4. And interval notation, I will just write from negative infinity to 3, union 3 to 4, union 4 to infinity. I knew I wouldn't have enough space, but I try my best. Yeah. All right, so that's that. Now, for the range, well, be careful. In our situation here, y cannot be equal to 1 because the curve never crosses 1. Sometimes, even though you have a horizontal asymptote at 1, but the curve might still cross 1, so you have to be careful. Here is just a quick example. Maybe, let's say this right here is your horizontal asymptote, at y equals 1. But maybe your curve could be like this, right? And then the other one goes like this part, and then another part like this, right? The 3 pieces rational function, that kind of thing. So be really careful. The curve can actually cross the horizontal axis somewhere, so be really careful with that. But in our situation, it never, right? Because there's nothing too tricky, and of course, it will suck that if the question says, hey, you know what? The curve actually extended like this. That would be too bad. No, we don't do that here. If this is the given picture, then we assume that it continues nicely in a similar fashion, so nothing crazy. So y cannot be equal to 1. There's another y for you that is not going to equal to what? 2. Yes, we have the open circle. So y cannot be equal to 2. And notice, yes, 1, 2, 3, 4. Okay, yes, the range is going to be from negative infinity to 1, union from 1 to 2, union 2 to infinity. And that will be pretty much it. And perhaps I will also make a little note right here. Because we have this open circle here, I will say that f of 4, this right here, is undefined, meaning that there is no answer based on the given information. Sometimes if you have like a closed circle here, suppose you have a closed circle here, then we will say that f of 4 is equal to this closed value, which is 3. Right, that will be it. But we didn't. Of course, don't change the equation on your own. That was just an example. So this right here covers pretty much everything that you should know from the given graph, and this is the rational case. If you have any other questions, leave a comment down below and let me know. Hopefully this helps. That's it.